Hello, today we are going to discuss about the circular convolution using concentric circle method. There are two methods to perform circular convolution. First one is the concentric circle method and the another one is matrix multiplication method. In this video, we are going to discuss about the circular convolution using concentric circle method. Let us go through a problem. Find the circular convolution of two finite duration sequences x1 of n is equal to 1 minus 1 minus 2 3 and minus 1 and x2 of n is equal to 1 2 3. We have given two finite discrete time signals and we have to find out the circular convolution between x1 of n and x2 of n. Okay, right. That is denoted by x1 of n circular convolution x2 of n, and I'm going to write down this solution. Let us take the circular convolution between x1 of n and x2 of n as y of n. So we can say that y of n will be the circular convolution between x1 of n and x2 of n, and it is denoted by x1 of n circular convolution x2 of n. This is the representation of circular convolution. And n inside a circle, we can read it as x1 of n circular convolution x2 of n. Okay, right? Before proceeding, let us write down what we have given. We have x1 of n is equal to 1 minus 1 minus 2 3 minus 1 and x2 of n is equal to 1 comma 2 comma 3. Let us find the length of the sequence in both cases. In the case of x1 of n, the length of sequence is 1 2 3 4 5. Means the length of sequence is 5. Here length is equal to 5. And what about the second signal x2 of n? Here the length of sequence is 1 2 3. Means the length means the number of elements in each signal. The number of elements in x1 of n is equal to 1 2 3 4 5. So the length is, we can say that the length is 5. And in the case of second signal, we have only 3 elements, so the length is 3. In order to perform the circular convolution, both signals must be of same length. Please note that in order to perform circular convolution between two signals, the length should be same. But in this case, we have a mismatch between the signals because the first signal, in the case of first signal, the length is 5 and that of the second signal is 3. So we have to, somehow we have to make the length same. So what we have to do is put 2 zeros with the second signal so that the length becomes same. That is x2 of n is equal to 1 comma 2 comma 3 comma 0 comma 0. Now the length is equal to 1 2 3 4 5. Now total elements in this second signal x2 of n is equal to length is equal to 5, so that the length is 5. Now x1 of n and x2 of n are of same length. Now we can perform the circular convolution between x1 of n and that of x2 of n, as the length in both cases is same. Okay. Now let us go through the procedure. In order to perform the convolution between them, first we have to draw a circle. Okay. Okay, a circle is drawn and we have to put x1 of n in anti-clockwise direction onto the circle. Okay, what we are going to do is graph all points of x1 of n in the anti-clockwise or counterclockwise direction. So I'm going to start from here, that is x1 of first element of x1 of n, that is x1. Let us denote it as x1 of 0. This is x1 of 0, x1 of 1, x1 of 2, x1 of 3, and that of x1 of 4. This is x2 of 0, x2 of 1, and x2 of 2. Okay, x1 of 0, that is equal to value is equal to 1, and here I'm going to put x1 of 1, that is minus 1, and here I'm going to put the third element, that is x1 of 2, which is equal to minus 2, and here I'm going to put x1 of next element, x1 of 3, x1 of 3, which is equal to x1 of 3 is equal to 3, and finally I'm going to map, I'm going to put x1 of 3, sorry, x1 of 4, which is equal to minus 1. Next, this can be considered as step 1. Okay, in this step 1 we have to draw a circle, and we have to mark the all elements of signals x1 of n in anti-clockwise or counterclockwise direction. And next, we have to do, what we have to do is draw an inner circle. Okay, draw an inner circle, and graph all points of x2 of n. This is x2 of n. All points of x2 of n in clockwise direction. Please note that now we are going to mark all points of x2 of n in in clockwise direction. In the first case, x1 of n was written in anti-clockwise direction. Now we draw an inner circle, and I'm going to put the values of x2 of n in clockwise direction, and the care should be taken that the starting points of both x1 of n and x2 of n should be same. Means I started putting the values of x1 of n from this side, so I must have to start the labeling from this side onwards. Means both zeroth element x1 of 0, that should come together with x2 of 0. Okay, zeroth element in both cases should be same. Zeroth element of x1 of n and x2 of n, that should be in along the same line. Okay, first x2 of 0 is equal to 1. Now how to put the second value, but is that x2 of 1, that should be in clockwise direction, so that should be here x2 of 1. What is x2 of 1? Is equal to 2. Next element should be here x2 of, sorry, x2 of 2, that is equal to x2 of 2 is equal to, what is x2 of 2? 0, 1, 2, 3. And next, this is x2 of next element after 3, that is x2 of x2 of 3, x2 of 3, what is x2 of 3? That is equal to 0. And finally x2 of 4, that should be 0, that is 0 here. Okay, what we have done is I marked the first signal x1 of n in counterclockwise direction. 1, this one should be here. Next, minus 1, minus 2, 3, and minus 1. And next, the values of x2 of n, that is marked in clockwise direction in the inner circle, that is 1, 2, 3, and 2 zeros. Okay, right. Next, multiply corresponding samples in the two circles and obtain signal y of 0. That is, y of 0 is equal to multiply corresponding samples in the sense we have to multiply the signals along the same line, x2 of 0 with x1 of 0 and x2 of 1 with x1 of 4 and so on. So okay, so let us try to do that. I'm going to multiply this one with this one, 1 into 1, and add this with this 2 into minus 1, 2 into minus 1 plus this 3 into 3, 3 into 3 plus this 0 into minus 2, minus 2 into 0 plus this 0 into minus 1, 0 into minus 1. Now add this one. 2 into minus 1 become minus 2. Next, 3 into 3 becomes 9. 2 into 0, 0, and this one equal to 0. So, what I obtained is equal to 10 minus 2 gives 8. So, y of 0 is equal to 8. Now, let us go through this step 2. Step 2. In the step 2, what we have to do is rotate the inner circle in anti-clockwise direction by one sample and do the same procedure. Multiply multiply between the corresponding samples along the line. Means rotate the inner circle in anti-clockwise direction. Only rotate the inside circle. Okay. In anti-clockwise direction, by one sample, multiply the corresponding samples. Okay, as in the earlier case, to obtain the next value y of 1. Okay, so first we have to draw the outer circle in the same manner, then rotate this inner circle in anti-clockwise direction, so that this x2 of 0 should go towards x2 of 4 and this x2 of 4 should go to the x2 of 3 side and so on. So just to rotate the samples in the inner circle by one sample, just to give a one rotation in the clockwise direction by one sample. Okay, right. Just draw the outer circle as in the same manner, 1 minus 1 minus 2 3 and minus 1, 1 minus 1 minus 2 3 and minus 1. No change for that. Next, draw an inner circle to mark every samples along the same line, and in the previous case x2 of 0 is written besides the near to the x1 of 0. So I'm going to rotate this in clockwise direction by one sample. So x2 of 0 should go to the x2 of 1's place. Okay, previously it was with x1 of 0 along this line with x1 of 0. Now that will be with x1 of 0. Okay, so this should be our new x2 of 0. Okay, just rotated by one sample. So this x2 of 0 should go to the to this side. Okay, this side. Okay, that is equal to 1, and then this x2 of sorry, then x2 of 1 should go to the this side, means this one should be x2 of 1 and this should be x2 of 2 and the corresponding values are 2 and this is equal to 3. This should be x2 of 3. x2 of 3 is equal to 0. It is written over here, x2 of 3, that is equal to 0. is equal to 0, and finally this should be x2 of 4. x2 of 4 is equal to 0. That should come here. Okay, again multiply these values. I'm going to write the corresponding operation here. Then we will get y1 of n. y1 of n is equal to this 2 into 1. 2 into 1 plus this 3 into minus 1. 3 into minus 1 plus this is 0 into 3. 0 into 3 plus 0 into minus 2. 0 into minus 2 plus is 1 into minus 1. 1 into minus 1. Okay, then I am getting 2 into 1 become 2, then 3 into minus 1 become minus 3. 0 into 3 0, again 0 plus minus 1 into minus 1 gives minus 1. So that I am giving the answer as minus 2. Okay, next step 3. In this step 3 and in the preceding steps, repeat the above procedure until the inner circle first sample lines up with the first sample of the exterior circle. Okay, now in this similar way, draw the x1 of n in anti-clockwise direction, and now rotate the inner circle by one sample. Means rotate the inner circle in the previous case. In this step 2, the x2 of 0 was here. Now if we rotate it again in anti-clockwise direction, then we will be getting x2 of 0 from here onwards. So this x2 of 0 should be this x2 of 0 was with x1 of 0 in the previous case. Okay, sorry, x1 of 1. Now we have to rotate this x2 of 0 by one sample again, so that will be here. Okay, x2 of 0 and value is equal to 1, and then this will be x2 of 1 corresponding value is equal to 0. Then correspondingly this will be x2 of 2, and so and so. I'm not going to show the steps in detail. I'm just going to write down the values. I will be back to you after that. Okay, back to the video. Now I have written x2 of 0, x1, x2 of 1, x2 of 2, then x2 of 3, x2 of 4. Okay, then repeat the same procedure, multiply corresponding samples and add them together, so that we will be getting y of 2, that is equal to 3 into 1. 3 into 1 plus 0 into minus 1. 0 into minus 1 plus this 0 into 3. 0 into 3 plus this 1 into minus 2. 1 into minus 2 plus this 2 into minus 1. 2 into minus 1. This is equal to 3 plus 0 plus 0 plus, sorry, this one plus into minus become minus 2. Then plus into minus become minus. Again plus into minus become minus. So that I'm getting the answer as. Now in the next step, again rotate the inner circle again by one sample in clockwise direction and repeat the same procedure. I'm not going to explain, just I'm going to draw and I will be finding y of 3 and obtain corresponding sample y of 3 by multiplying and adding corresponding samples. 0 into 1 plus 0 into minus 1 plus 1 into 3 plus 2 into minus 2 plus 3 into minus 1. Then add them together. 0 plus 0 plus 3, then plus into minus become minus 4, again plus into minus become minus 3, so that I'm getting the answer as minus 4. Again rotate the inner circle once again in the counterclockwise direction by one sample and repeat the same procedure. Then I'm getting y of 4. Okay, this is the figure of our step 4. I mean the next step. Then I am getting y of 4. This is equal to 0 into 1 plus 1 into minus 1 plus 2 into 3 plus minus 2 into 3 plus 0 into minus 1. This one equal to 0 minus 1 plus 6 minus 6 plus 0. Then the result y of 4 will be minus 1. Now let us write the entire y of n, that will be the convoluted output of our two signals x1 of n and x2 of n. Okay, it is denoted by letter y of n, that is the circular convolution between x1 of n and x2 of n. That is equal to x1 of n circular convolution x2 of n, that is equal to y of 0 comma y of 1 comma y of 2 comma y of 3 and y of 4. Okay, let us put the signals together. What is our y of 0? That is obtained in step 1. y of 0 is equal to 8 comma, what is our y of 1, that is y of 1 we obtained is minus 2 comma, and y of 2 is equal to minus 1, and y of 3 obtained is minus 4, and finally y of 4 obtained is minus 4. That will be the result of our problem. Okay, thank you.